Hello. Let's talk about mollusks. Mollusks are kind of interesting, and they have a great fossil record, and so yeah, let's cover them. So you can see some of the important mollusk groups here. So at the top we have Tentaculites. That's been grouped with mollusks, mostly based on the shell affinity. Here we have, it looks like a bivalve, like a clam, but these two valves are actually cemented together. They cannot open or shut. These are called rostroconchs. They've been proposed to be relatives, like on the way to becoming a bivalve, but they may actually be a side group and a little more like a snail or something, and not particularly bivalve like. It's hard to say. It's still an area of open research. You've got some mollusks that have no shell, and we normally define mollusks by their shell, which is very convenient for fossils because that's all you've got. So these guys usually do not fossilize. And then you've got the chitons, Chiton, because they live on rocks. Yeah. And these are multi-plate. They usually have 8 plates, like a head, tail, and 6 middles, and a sort of a mantle around the outside. Highly armored. I cut my thumb pretty badly trying to carve one off of a rock in Florida as a youth. Yeah, so I remember them. Then you got your regular bivalves. You got your monoplacophorans. They are interesting and primitive. We're going to get to those. Your gastropods, your nautiloids, which are part of the cephalopods, and then you get a variety of the old things over here, including this guy, which is a hyolith. And hyoliths, we're not completely sure that those are mollusks, but they do have 2 tentacles that stick out at the top, and they have a little shell, actually a long shell for the body and a little shell for the top. They could be something like a bivalve. For right now, let's just say their position is uncertain. But yeah, these are the mollusks. This is a fantastic slide set on early mollusks. And this comes to us from Uppsala University. Yeah, there's a lecturer there who absolutely knocked it out of the park on this, did a better job than I could do. So this is where we're going to start for the overview of what mollusks are, and then we'll go on and we'll get into some of the earliest branches and the sort of problematic mollusks that are out there. As you can see on the top, we have a radula. Look at this. So gastropods have a radula, and it's just a series of little tiny teeth that they're going to rasp against something, and they'll end up scraping off whatever's on the rock. This is their eating mechanism. These are little hard teeth. They're usually not mineralized properly, but they can be of durable substances. The radulas often will not fossilize except in conditions where you actually get some soft tissue fossilizing, but they're quite hard and raspy. Yeah, so let's get into it. All right, so inside of the mollusk shell, you're going to have different layers, and there's a prismatic layer that you will find on some mollusks and not others, and that is going to be one of the defining features of certain types of mollusks. In a normal one, you'll have your periostracum. This is going to be your outside. It's going to be organic. Your ostracum, that's going to be the main part of the shell. It's going to be made of calcite or aragonite, depending on what we're dealing with. And then you'll have your nacreous layer, your hypostracum. That's often going to look like a pearl. So like when you open up an oyster, that's the nacreous layer that you are seeing in there. And it's just a thin layer on the surface. And the rest of the buildup is this sort of ostracum that makes up the rest of the shell. Radula, look at that. And this is a nice little scanning electron micrograph of a radula. Look at all those little raspy hard parts. And just like you see in our little snail mouth up here, or maybe that's a limpet actually, you're going to have different types with different locations for them, and they're very useful for scraping things to eat off rocks. A lot of gastropods in particular are going to be grazers. Some of these other groups, things like cephalopods, are going to be predators. They're going to hunt for a living. Bivalves are going to filter for a living. But gastropods are grazers, which means they often come into these paleo environments. And as the gastropods go up, they just sort of clean off the surfaces. And yeah, they end up basically out competing, if you like, a lot of the Paleozoic animals that I'm particularly fond of. So that's one of the reasons why I'm not a big fan of gastropods. But you know what? That doesn't have to be. I don't have to pass that bias on to you. So yeah, it's like a little ribbon with things that look like teeth arranged in little rows. And that's going to be a gastropod feature, but also probably a early molluscan feature. We think things like gastropods are some of the first mollusks around. So, other features you would find in a mollusk. We're going to call it the foot. And so this is just going to be a muscular extension that's going to come outside of the shell. Like the human tongue, this can be molded into different shapes. It can sort of dig, it can move, it can do a lot of stuff that helps to keep our mollusk alive. Here are the extant mollusks. These are the 8 classes that you get. And so there are 2 classes. At least at the time of this, there have been proposals to maybe kind of merge these things together, and we would have to look and check if that has gone through or if we're keeping them apart. But these are both shell-less, worm-like mollusks, but genetically they are very close to mollusks and in what they do. Cephalopods, these are going to be our predator mollusks, highly intelligent, very interesting mollusks. Gastropods, things like snails. You got your polyplacophorans with many plates on their back, and you got your monoplacophorans with 1 shell on their back, but they're going to have reduplicated organs underneath that shell. So yeah, many shells and just probably the 1 set of organs versus 1 shell with many sets of organs. Yeah, those are your choices down. And these are both very primitive members of the Mollusca. And they actually, between the 2 of these, they bear a lot of resemblance to the earliest mollusk fossils that we have. Some other weird ones. You got bivalves here, and those get going rather late. There are some things in the Lower Cambrian that look like bivalves, but are not bivalves. Don't appear to be related at all. Yeah, and so it's a morphology that's evolved twice. Instead of having sort of 1 shell on your back, you just sort of duplicate it, and you're like, okay, I'll have 1 shell on each side. Yeah. And then scaphopods are called tusk shells. They're going to consume at the bottom, and then they're going to expel waste at the top. Yeah, it's like a little chimney. So let's hit some of these groups, the prominent groups. Gastropods, these are going to include your snails, but also some of your shell-less gastropods. Things like sea slugs, things like nudibranchs, for example. They're going to be defined, at least in the modern ones, by their genetics. They're going to be defined in the fossil record mainly by their shell, but in the rare cases when you get it, they'll be defined by their radula. And remember, the radula are the rasping tongue organs that you find in these gastropods. The shell is normally going to have torsion in it, and the most common thing, torsion's like curling, the most common thing is for it to get larger and kind of move to the sides. So gastropods like this would not be particularly good swimmers, potentially, if they were not bilaterally symmetric. You know, they're generating an asymmetric shell. But there are gastropods that make a living by swimming, and they'll either have a small sort of internal shell, or there are some that have evolved a symmetrical shell that then helps you swim, in the way that having, you know, a paddle on either side of the canoe helps keep you going straight. Yeah. All right, here are some examples of beautiful gastropods, some that don't even particularly look like gastropods, but you can see that sort of curl in the shell. And the curl is kind of even there in these cowrie shells at the top. Look at that murex. What a great looking shell that is. Quite often when there is a curled gastropod shell like this, these guys down here, which look sort of like turritella, and this murex will have a little door on here. And it's usually not a particularly well mineralized door. It's usually more like chitin, like a little rubbery, bendy door. But that can be pulled in so as to close the aperture, so that the animal has a little bit more protection if there's something dangerous around. So operculum, Operculum, the same word we use with the little covering on bryozoa. Yeah, operculum. There you go. All right. So, done with gastropods for now. Let's talk about Polyplacophora. So yeah, all the extant ones have 8 plates exactly, and the plates are slightly different. They are going to have some sense organs. On some of these, they can actually see a little bit from this sort of skirt around the outside. It looks like that's just the sort of like the muscular foot coming out, but it is heavily armored. It is just not made with this same sort of shell. So you can see the plates are made of aragonite with some of that chitin underneath. They're a little bit bendy, and they can be quite beautiful. Yeah, so that's polyplacophorans, which are also called chitons because they live on things at the ocean. And here are some beautiful chitons. Look at those. Count their little middle segments. This one over here is actually quite giant. These giant chitons get about that big. They're pretty awesome when you see them. Yeah. All right. Now let's go to the monoplacophorans. So they're in a group called the Triblidida. Triblidida, I guess is how you would say that. And these are the real monoplacophorans, and the shell just looks like kind of like the shell you would get on a limpet or a one of those slipper snails that you get, particularly on the East Coast. However, if you were to look inside, they're going to have a little mouth up here, and they are going to have multiple. Look at these gills. So duplication of these gills. If you look at the inside of the shell, there will be little scars on there where some of these duplicated organs underneath the gills would have set. So they have serialization, multiple copies of the same thing without being segmented. Because like in an annelid, you'll have different segments, and you'll have like 3 segments in the row, each of which will have a little contractile thing that functions kind of like a heart. And so you can say, oh, they have 3 hearts. But they're on separate segments, and so it's just 3 repeats of the same thing. These are all in the same segment, and yeah, they are there. So it's duplication, serialization, because there's a whole bunch of them, not just 2. Okay, next group. So we've done the monoplacophora, which are also called Triblidida, and we've done the polyplacophora, and we've done the gastropods. So now let's do the bivalves. And here's some bivalves. There's a nice giant clam down here, and that's probably a fire scallop. I don't know. It's a weird angle for it. But yeah, they're going to have a pair of valves, and there'll be a right and a left. There are going to be teeth in between those valves. For most of them, there are some groups like pen clams that don't have teeth to hold the 2 shells together. And yeah, some of these are going to be mostly sedentary. They'll have an earlier life stage where the little larva is able to move around and find a spot, and then some will be mobile like this guy. Others will be sedentary like this one, as their main mode of life later on. The ones that move will move with a water siphon sort of thing. So they'll take in some water and then squeeze it out and use that to sort of propel themselves along. It's kind of neat. We'll probably watch a little video that has that. Okay, so mollusks in general seem to have split off from the annelids. That is apparently the closest clade, although things get really murky down in here. and like the exact placement of brachiopods. Sometimes they end up close to mollusks on the tree, even though the animals are seemingly fairly different. Yeah, it's an early branch, but if you look at these numbers here, is a branch that, according to the molecular phylogeny, probably dates back to around the time of the start of the Cambrian. So these are probably creatures from the Cambrian explosion, the things that came in and wiped out and replaced the Ediacarans that came before them. All right. So, what's a mollusk? We know the mollusks now. What are the things that mollusks have in common? I think that's worth talking about. So, they're going to have gills in the cavity in the mantle. So, the mantle is going to cover up the organs here. And the gills will normally have water pumped over them in some way. And that is how they're going to keep themselves oxygenated and get rid of their CO2. When they have a shell, they don't all, but when they do, it's usually going to be calcium carbonate built on a chitin sort of underlayer. And they're going to grow by accretion. They're going to add it layer at the time to the edge. And the mantle is what's going to secrete the shell, basically. Yeah. Now let's go deep, deep, deep into history. Actually, this is a good point to pause. Let's break this up into two segments just so you can go get a drink or something like that. So pause right here, and now let's go back to the old mollusks in the next section.